Good evening, mini bootcamp students, and welcome back to Lambda School's free mini bootcamp. Um, kind of just our regular what we're doing here tonight. This is part of a 12 lesson, 3-week mini bootcamp provided free of charge by Lambda School, taught by myself, Dan Frainer. And we are on lesson 10 of 12 tonight. So we are nearing the end. That being said, those of you that are waiting kind of till the end of this to join our full-time program, please don't wait any longer and get your applications in. Those of you who don't know what our full-time program is, it is a 6-month fully immersive computer science program. So Lambda School Academy of Computer Science, where we kind of go over, give a real full computer science education. Where we go above and beyond what a normal boot camp model is. And, we do go over all of the web development and front end and back end development, and React and Node and databases, Mongo and Postgres. And then we also go into a full computer science development, computer science education, where, we go deep into computer architecture. We work with C, we work with Python. It's a lot of algorithms. We really go really in depth, and it really sets us apart from all the other schools out there. It is a 6-month fully immersive course, so that's Monday through Friday, 8 a.m. to 5 p.m. Pacific. And it lasts for 6 months. And by the time you're done, we expect you to be a fully qualified software engineer, able to go out and get a job in the field. The unique thing about our school is that we charge nothing up front. So nothing, you pay zero until you are finished with school and you go out and get a software engineer job. And then you only pay if we deliver on our end of the promise that we've taught you well enough so you can go out and get a job making more than $50,000 a year in the software field, technology field. And only then, once you start that position, do you pay us back. So it's really an awesome opportunity we have to really de-risk the education. We share that risk with you. You put the time in, you risk your time of 6 months, we risk our business, so we have to provide you with exactly what you need. And as long as you're there and you put that time in and you put that hard work in, we're going to get you a job you'll get a job after the class is over, and then we'll all be happy. This mini boot camp here is free of charge, so we're just kind of keep going over the basics of introduction to web development here. This 12 lesson class includes kind of everything that makes up a front end development. It's kind of the basics, where we go HTML and CSS. We go into JavaScript, which we go pretty heavy into JavaScript, and we're on the second to last of our JavaScript modules or lessons today. And we go pretty advanced. Tonight's lesson is going to be pretty advanced, and tomorrow's is going to be really advanced. And then we kind of wrap it all up, and we'll do that in lesson 12, which will be in 2 days from now. And we talk about DOM manipulation and HTML, CSS, JavaScript kind of all together working harmoniously to build a front-end web application. And we'll actually do that on Thursday afternoon or Thursday evening, 2 days from now. Other than that, let's get started with tonight's lesson, which is going to be on a concept in JavaScript called closure. Let me share my screen. I'd like to remind everyone, if you're watching live, please join us in the Lambda School Prep Slack channel and into the questions channel, where I'll be monitoring the questions channel as we go, and I'll tend to give a bit of time at the end of the lesson today to answer any questions you have. There is also, each individual lesson has a lessons channel, so even if you're not watching live, please join us in one of those lessons channels if you have any issues or questions with the assignment that you're working on, or with the lesson at hand. So each lesson has their own individual channel. We also have a help channel, which is kind of a generic help channel. If you're looking for help on a specific lesson question, I would put that in the lessons channel. Otherwise, put it in help. And there's usually a couple folks out there monitoring that. And yeah, other than that, during the live instruction tonight, please post your questions in the questions channel. Great. So kind of a little recap of what we did last night or yesterday. We started talking about callback functions. We started talking about how, when we create a function, we are essentially creating a variable, right? That's called print's name that points to a function. We'll give it a name, and we'll just say this function console logs name. So since we have access to that function by using its name, we can actually pass that function name around just as we would any variable. Let's name equals Dan. We can console log the name. We'll see there we have Dan. We can also console log print name. Nothing will show up on the screen in our little Replit browser here, but we'll see that we have access to that function, print's name. And so we learned that we can create a function that receives another function as an argument. And so let's say it does something. And it's going to take a username and what we call a callback. So the callback is going to be a function that is passed to another function as an argument. And then we can just say return CB, and we can call that function. And we can call it using username. That's how we're going to work this function. Let's go. Name. And then we can say does something. We can pass in the name or first name. And then we can pass in the function itself that we want it to be called. So we'll call that print name. So what's happening here is that first name is being passed into the does something function as username. So Dan is going to be the username. Then print's name is going to be passed into the CB argument. So CB is going to point to this function right here. We can then call that function using the username, and we'll see that it just console logs Dan. We'll say name is, we're going to use some ES6 string interpolation right here. There we go. And we'll see name is Dan. So this is called a callback function. Right? So we are able to pass functions around between other functions. We can pass it into an object. We can pass it just as we would any other variable, right? And so we, talked a little bit about some array functions, array methods, excuse me. Let's see, const are. We have an array. We talked about the for each. We talked about map. And we talked about reduce. And so for each is essentially just going to take a callback as its only argument and run a loop. And each item in that loop, it's going to pass into the callback. So let's go function. We're going to give it one argument of item. And we're going to say console log item. And we'll see that it's going to run a loop, and for each item in this array, it's just going to console log the item. Pretty simple. It just runs the function, the callback function on each item. Map, on the other hand, is going to pass the item, each item, into the callback function and create a new array with that new, let's go, mapped, going to give us a new array back with all of the items changed by whatever the callback had it do. So let's say return item plus 2. So we should get 3, 4, 5, 6. We're going to console log it. We got 3, 4, 5, 6. A new array with that in it. Reduce, as we learned, is a little bit more complicated. So reduce's job is to take the array, pass each item into a callback that reduces the array down to one item, one data type, right? So the callback that reduce gets, remember, it's the only one of the 3 that gets 2 arguments. And the first one was the accumulator, or starting point, and the second one was the item. And so we can just say accumulator turn later plus item. So this is going to add all of the items up. And we need to const reduced now we can see it added all those items up because we have passed the accumulator plus the item. So for each time, the accumulator is whatever is returned from that last function. So in the first case, it's going to be 1 plus 2. The accumulator is now going to be 3. 3 plus 3, accumulator is now going to be 6. 6 plus 4, accumulator is now going to be 10. It's finished, and that's what it returns. So those are callback functions. It's worthwhile continuing to write reduce to try to figure out reduce. It is a difficult concept and a difficult method to really fully understand. But once you fully understand reduce, it becomes a very powerful method, and you can really do a lot of awesome things with reduce. Reduce and map are essentially what run most all data science. Everything is mapped to a certain way and then reduced down to one value. It reduces really an amazing method, but it does take some practice and does take some time to really get it down. So that's callbacks are a pretty advanced topic. And so, this topics we don't really fully expect you to completely understand. But we are merely introducing you to these topics. And if you do decide to join us for the full course, this stuff is explained and is revisited in depth. So keep that in mind. Work on it as hard as you can. If you are joining us for the full course, it is worthwhile to work on these, especially these last 3 lessons. The last 3 JavaScript lessons in the mini bootcamp here, because we use this stuff a lot in JavaScript. And the better understanding you have of callbacks and closure and objects even, the better you're going to do in the class and the better time you'll have with it. So today we're going to talk about closure. Closure is a concept in JavaScript that is very powerful. I say that a lot, but it is. And we're going to spend our time today just talking about this one topic. And it's going to probably be a little confusing to you at first. But just know that, just like callbacks, once you get this, a lot of things open up to you in JavaScript. So we learned yesterday, and just now we went over JavaScripts are what we call first-class objects. What that means is that we can use functions in a very flexible manner. We've seen that we can give a function. We can write a function, myfunc, and we have access to that function variable. We can even write our function as a variable. Equals. And so now we have access to this variable. We can pass that variable around as we please. We can put functions in objects, remember. So const obj equals, when we put a function on an object, method, we call it a method. We can even put functions in arrays. So functions are available to us just like any other data type, just like any variable, a string, a Boolean, a number, an object, an array. They're available to us as we wish, right? We can put, myfunc in a variable or in an array. So we can have an array of functions. We can pass functions into other functions, as we just saw. That's our callback functions. And finally, we can return a function from another function. And when we do that, that function that returns the new function is called a higher order function. The idea, and so let me go kind of backtrack a little bit and talk about function scope. So we have a function. And got to spell it right. When we have a function, every function has what's called function scope. So it's the scope of the function, and it's the variables that are available and the data that's available to that function and to that function only. Let's see here. We have, if it is outside of a function, if it is on the top level, this is called a global scope. So let's say first name is Dan. We're not going to go super deep into scope right now because it's a very advanced topic, but we need to understand scope in order to understand callback functions. So let's say console log first name. When I call this function, the function is able to reach outside of it, anywhere outside of the function, and grab any variables it wants, right? So it can say, what is first name out there? Whoops. First, not fist. And we can see that it console logs Dan. So now let's do this. Let us console log first name. And we're not going to do that. We're going to. Now we can see that we have a variable inside of this function, and we are trying to call console log it outside of the function. So we're trying to reach into the function and grab it out to call it. And we'll see that first name is not defined. It's because when inside of a function can create its own variables, but whatever is wrapped in these braces is only available to that function. It's only available to myfunc. So if we want to have access to anything in the function itself, we have to return it. So I can return first name. Now I can then say first name equals myfunc. And now I can console log it. Now we get Dan. So just know that when you create a variable inside of a function, that is called function scope. And it has its own scope. It has its own variables. It can reach out and grab variables and bring them in, but nothing can reach into a function and pull variables or data out of it. The only way to get data out of a function is to use the return function or return keyword. And still then, we don't have access to first name. You know, I can do this. I had to reassign first name to whatever is returned from it. So that is function scope. And if we can understand function scope, we can start to understand closure. And so let's say we had a function, and instead of returning first name, we returned another function. And in there, we console log hi. Just do that. And so let's do this. So let's see, we're going to run my function. And then it's going to create a variable. It doesn't do anything with it. And it returns another function. And so whatever I assign that first name variable to, and let's not call it first name anymore. Let's call it result of function. So now this is going to return another function. This is going to return that function, and result of function is now going to be equal to a function. And let's see, we're going to console log result of function, and now we see that it is a function. How do we run a function? We put the keys on the car in the ignition by using our parentheses. We call it, and now we can see, oops, we don't need a console log. Now we can just see it console logs hi. So now we have access to this function. So if I created a variable inside of here, const last name equals my last name, right? This function, this level cannot go in and grab that last name. All right, we'll see right here. So last name, right? We can't go into functions and grab last name is not defined. Can't go into functions and grab variables out of them. But as we learned just now, we can reach outside of a function and pull variables into it. So let's see. Let's go like this. And now we can say, give me first name plus last name. So we can reach outside of this function. Since this function right here, right, is still inside of this function scope, we can reach out and grab that variable. Since this, you know, if we did console log last name, it is not inside of this function scope where last name was created. So we can't reach into there and grab it. Just have to remember that scope, any function can reach out of itself and grab any other variable and bring it in. But nothing can reach into a function and bring it out. That's a one-way street only. So let's see here. Now we have Dan Frainer as our, we have console log Dan Frainer. So we can see that we have returned a new function. That new function has created its own function scope. It's created a it has created a variable inside of it, and now it's reaching out and grabbing the scope of the function that was given to it. So now instead of first name there, let's give it a first name to begin with. And now it has an argument. And inside of this function scope, that argument lives. And now we can give it, let's go last name. So now we have a function called myFunction that takes an argument called the first name. It returns a new function. So it's going to have memory of the first name here. And then we can pass it another argument when we call it of last name. So we'll see if I run it like this, result of function, myFunction Dan. So that's going to return a new function. It's still going to have memory of that name. But it's also going to expect us to give it another. Since we don't give it another, we'll see if Dan plus undefined. But if we give it there, we'll see Dan Frainer. And this is called a higher order function now. myFunction is called a higher order function because it's returning a function. And this function is going to keep memory of when it was created and the scope that it was created in. And it's going to always have access to that scope. All right. So let's do this in a little bit of a different way. We're going to do make multiplier. We're going to give it the number to multiply by the first number, first num, and then we want to give it a second num. And now we're going to return in that function first num times second num. Okay, so let's step through this and then see what we're doing. So this function is going to take a single argument called first num, right? It's called make multiplier. It's going to take a single argument called first num. Okay. It is going to return another function, right? So what we can do is we can say const times 5. And we can say times 5 equals make multiplier of 5. So now we have access to times 5 is going to be equal to this function right here. When we've returned this function, it still has memory of the scope that it was created in, and that first num is part of that scope. So it's going to have memory of 5. And now we can just call times 5 whenever we want and give it one number, and it's going to multiply that number by 5 and return it. Let's go times 5, 10. And we can see 50. Times 5, 100. 500. And this is called, this is our closure right here. Closure is when we've returned another function that has memory of the scope that it was created in. And so this is a very advanced topic. It is something that's takes a lot of practice and a lot of getting used to and really understanding what's happening here. But let's step through this once more. We can talk about it because this is about it of what we're covering tonight. This is one of those things that I can probably explain to you all night long, and it might not click to you until you start playing with it and working with it. So when we create the make multiplier function, we create it by taking one argument, that first number, right? And we can do, well, let's just keep it like that with 5 right now. So it's going to take a single number and return a function. And essentially, it's just going to return this function. So we can say times 5, and we can assign times 5 to whatever make multiplier returns, which is going to be this function here. That function is going to take an argument itself. It's going to have memory of the scope that it was created in. So it's going to know where first number came from. And then it's just going to return it multiplied by the second number. So in this case, times 5 is going to equal make multiplier 5, which is going to be this function that's returned from the make multiplier function. And this function is going to, we can call times 5 however many times we want with however many numbers we want. And it will always multiply that number by 5 and return it. Now, make multiplier doesn't care if it's 5 or what the number you give it for first number is. But since we've given it 5 and we've assigned times 5 to that function, that's what it's going to be. So that being said, we can create another function times 4 equals make multiplier 4. Const. So now we're going to have, these two are going to be totally different, right? Make multiplier 4 is going to return a function, but it's going to have memory of the scope it was created in, which first num equaled 4. Times 5 is going to be make multiplier. It's going to be this function, but it's going to have memory of the scope it was in which first number was 5. So now we can go times 4. We'll say 4 times 4 is going to be 16. So you can see here how this can get really powerful in a programming language. At first, make multiplier, well, we can multiply whatever we want, 5 times 4 whenever we want. But when you have a bunch of other stuff going on in here and the scope that it creates, the outer function creates, then it returns that inner function and we can add stuff to it. It makes the language incredibly powerful. And this is called closure. We close that function into this scope, and this function remembers the scope that it was created in. Okay, every function remembers the scope it was created in. Make multiplier remembers the scope it was created in. It's got access to variables outside of it. And so that really covers it for tonight. Using this closure, we can do so many interesting things with it. We can make cache functions which store, data that we've already seen once, and then we can go back and get it instantly instead of running a function again. We can create private variables in here, so bank account numbers or passwords and things like that aren't accessible. If I had const password equals C123, and then I tried to console log password out here, we're going to get an error. Password is not defined. But we can use that in there to, when this function is run, to go in and log into something and grab some data for us. It makes it very secure in that you can't even reach in and grab that password from the function. It's got that in its closure scope. We can customize the function's behavior just like we did right here with returning that first num. So now we'll always have a number of 5 that we can multiply any number by. It's a function that returns any number multiplied by 5 that we want to pass to it. this simple little multiplication function is really just the tip of the iceberg when it comes to closure. There are some resources in our README on GitHub that I'd love for you guys to take a look at. The first is there's a book called Eloquent JavaScript. And Eloquent JavaScript is not an easy read by any means. But chapter 5 talks about higher order functions. If you are planning on either joining us for the full-time program or continuing on your own and learning JavaScript, I highly suggest you read Eloquent JavaScript, especially chapters 1 through 5. There is a lot of material in here. And it really goes in depth about, it's a little more dense than our class here, so it may take a couple of practices and work through, but it's really great. Here's the higher order functions here. We can kind of see that we get they do a greater than 10 function here. There is another resource on there. And it's understanding JavaScript closures with ease. So it goes through and talks about closures quite a bit, and it does this in a way that's using jQuery, so that might be a little out of the scope of our class. But you can kind of get a good example, and here we go. Oh, I guess they used my same exact one. I must have gotten it from them. And there are some really great resources in our in that README. Before I open it up to questions, let me go through something real quick with our tests for tonight and tomorrow night's lessons. So just want to let you know, when we come in here, we can see tests, lesson 8, which we haven't gotten to yet, actually. So this might not work 100%. When we run tests, there were some errors when we first started this class in our test suite. If you do want to run the tests for tonight's homework, please come onto GitHub on the Lambda School pre-course. Make your way into, let's start that from the beginning, lesson 10. Make your way into homework, tests, then click on that test. If you want to run the tests tonight, I highly suggest just copying this entire document here, which it's only 50 lines, and then pasting it into whatever, let's see, I don't know if I have it on my computer, but paste it into the test file that's in your test file that's in your file. It's in the same exact place in the lesson 10 file or folder, in the homework folder, in the tests, and it's called JSVII test. Just copy and paste this from the GitHub into your test, and it'll run fine. If you don't, then there's going to be some broken tests in there that weren't caught before we started the class. I just want to make sure that those of you that do want to work through this and have the tests, that you're able to do that. And actually, I'll even post this as a snippet on the general chat, and you can go there and copy paste it from the general chat. That's for JS7. Great. Now that I've gotten that taken care of, I'd love to open it up for questions. If you have any questions, please post them in the questions channel. Cool. Thanks, James, for posting that string template literal. Yeah, so that's an ES6 way of doing things. When I posted, const name equals and console log You can do either this, which is an ES6 or ES5 and prior way of doing things. We can add strings together and it creates a new string. You can say, hi, my name is Dan. Or ES6 gives us string templates. So if you want to use a string template, you're more than welcome to. Just know that the quotes are actually backticks. That's not a single quote. So keep that in mind. This is not a single quote. That is a backtick. On a Mac, it is on the upper left-hand corner of your keyboard. I don't know where it is on a Windows keyboard. But those are backticks, and then you can use variables directly inside of string by wrapping it in that $ and those braces. Or if you don't want to worry about it, you can just use the old-fashioned way, which is totally fine as well. Let's see. Mike, try to get into functional programming. That is definitely a path you can take, John. And that's what's cool about JavaScript too, is that JavaScript doesn't subscribe to any paradigm, any programming paradigm fully, right? We can, most of the things you'll learn are object-oriented in JavaScript. But as we know, and if if any of you have worked in any object-oriented languages prior, it's not really an object-oriented language. JavaScript can absolutely be written as a functional programming language, but it's not really a functional language. It kind of does a lot of everything pretty decent, and it really depends on you and which way you want to take it. When we get into stuff like Redux, which is incredibly functional. And then you work with React, which is more object-oriented. So it's kind of a mixed bag there. And functional languages are awesome, and they're also tough. So this is the same as currying, yes. And so you were to take these concepts, and you can curry easily with this. Yep. As far as functional pointers in C++ or delegates in C#, it's been a long time since I've worked with C#. I'm going to have to defer that question. I'm not 100% sure. Does every function, in a sense, create closure? Every function creates its own scope. But in essence, what we're talking about when we say closure is that we have closed this function. We've created closure in this function by creating it inside of the function scope there. So it has memory of that scope. Every function does create its own scope. So I'll leave it at that. Wait for some more questions. Let's see if I can help explain question 2 in the lesson of the day. Sure, I got a minute. Let's go in and check out question 2. But for the most part, any questions you have regarding the actual assignments, please put those in the assignment of the lesson. Okay, so we're talking about a cache function here. So we use closure to create a cache for the callback function. The function you should accept a single argument and invoke callback with that argument. Okay, so this one's a little more tough. And function you return is invoked with the argument should save that argument and its result. This is a tough one. And so those of you that are following along that are using the mini boot camp as your pre-course work, these two lessons, tonight's and tomorrow night's lessons, are not required for the pre-course work. So these are highly recommended, but not required. So if you can't totally figure these out, don't worry too much. Essentially, in here, let's do this. Try to do it quick. Let's go. Hash function. We're going to return another function that's going to take an argument, right? So what we want to do is return CB arg. What we're doing here in this question is we're creating a cache. And a cache is something that where we've run that function in real life. A cache would be used for, say you have a very memory intensive, time intensive process that you don't want to run every single time you get new data. You know that the function is going to return the same thing with the same data for the same argument. So you can keep a record of that. Usually, I'll give you a hint on this. We're going to use an object, and we're going to use the argument as the key and the value as whatever the CB returns. So I don't want to give you the complete answer to this right now, but we're going to say create object. Then we're going to find the result of the CB, which is going to be that. If argument has been seen, return value from cache. Otherwise, return CB. So that's essentially how it's going to go. It's a tough question, and it's going to take a while. Please work in lesson 10 channel, work with each other to kind of figure out a way of doing this. It is going to take a while. There are only 2 questions in tonight's assignment, but they're really tough questions. And so, I wouldn't put it past you to spend a couple hours on them. They're really tough questions, and work with each other and help out. Ifs are out of scope of this lesson. That's kind of getting away from the general use of what closure is. That's more of just creating one big closed off scope. David, the function is closed with no return function. Does it then release the memory? Eventually. There is some garbage collection that goes on behind the scenes. Depends on what environment you're running JavaScript in, browser, Node, etc. It does all that automatically for us, so we don't have to worry about garbage collection in JavaScript. But it will release the memory. Cool. That's it for tonight, everybody. Thank you very much for tuning in. Like I said, this is a really tough lesson. This is a tough subject matter, and this is getting pretty advanced as far as JavaScript goes. But work on these, read those extra resources that we've given you at the bottom of the README. Work with each other in that lesson 10 channel. Work through it. And then tomorrow night, we're going to talk about something that's pretty tough as well. Then we're done with JavaScript for a moment. And we'll go into, well, not done with JavaScript. We're done with like our advanced JavaScript. We're going to go into DOM manipulation and kind of tying everything together on Thursday in 2 days from now. So thanks, everyone. And we'll see you tomorrow evening.